Okay, so we are working on the review prior to your Topic 7 test that you will take tomorrow. And again, boys and girls, there is no math meeting today, so you are watching this video where I will go over these review problems instead of discussing them during our math meeting. So if you have not already completed pages 285 and 286, then you need to stop this video and go and complete that work first, and then you can come back to check your work. Let's start with question number 1. Courtney has 36 photos to arrange on a gallery wall. How many arrays, so we're going back, that's a 3rd grade skill we're revisiting, can Courtney make with 36 photos? List all the possible arrays. Well, I'm not going to sit here and draw them out. I know that arrays have those like boxes. Some of you drew them with little X's last year. For example, an array for 9 would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So instead of drawing the array, we're going to use our background knowledge of multiplication and the factors of 36, because we know that just like this one, this is representing the factors 3 times 3. So now let's think of 36. Well, I know that I can make an array of 1 and 36, or 1 by 36. I'm just going to write that 1 times 36. Now, 36 is even, so 2 can also go into 36. I could make an array that's 2 by 18. I know that 3 goes into the number 3, and it also goes into the number 6 evenly, so 3 must go into 36. That'd be 3 times 12. And I know my basic facts, so I know that 4 times 9 is also equal to 36. I can create an array that is a 6 by 6 array, because 6 times 6 is equal to 36. Now, if I continue going, the number 7 does not go into 36. Neither does 8, and so now I'm back at 9. So now I could do an array that is a 9 by 4. I could also do an additional array that is a 12 by 3. I can also do an 18 by 2 and a 36 by 1. So if we look, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I can do 9 possible arrays. Part B. How many factors are there for 36? Well, that's really what we just did in solving for the possible arrays. It is the same thought process. They want us to write them. And what do you notice about the number of factors of 36 and the number of arrays that Courtney can make with those photos? Well, we already solved that there are 9 possible arrays. So let's see what happens when we list the factors for 36. I know that 1 times 36 is equal to 36. And then I said 2 times 18. 3 multiplied by 12, 4 by 9, and then I also have that 6 by 6, but what we're going to do is just include the number 6 here because we don't need to write that twice. So now how many factors do we count? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we just happen to have the same number of factors and possible arrays. Part C. Write all the factor pairs for 36. Is 36 prime or composite? So again, 1 and 36, 2, I feel like we're repeating ourselves, but that's okay. 3 times 12, 4 times 9, 6 times 6. Now we have all of our factor pairs. So we need to know if 36 is prime or composite. So what you guys learned about the word composite is that A composite number has more than two factors. For example, 1 times 2 is equal to 2. There is no other way to get that product of 2. You only have these two factors that will get you there. Even if you turned and flipped them around, 2 times 1 is equal to 2, you still, when listing the factors, would have 1 and 2. So that is an example of a prime number. So obviously we see that there are 9 factors, so 36 is a composite number. Because it has 9 factors. Moving right along, question number 2. Determine whether the numbers in each list are factors or multiples of 16. So if we start at 16 and we were skip counting, this would be like 16 times 1. And then we continue on, would we reach 48? That wouldn't be 16 times 2, but if we continued and multiplied 16 times 3, we would arrive at 48. This is a multiple. 1, 2, and 4. Well, if you start at 16 and you start skip counting, you are not going to arrive at the number 1. These are factors of 16. Same thing with number 8. You cannot start at the number 16 and begin skip counting and arrive at 8. 8 is a factor of 16. Last one, 32 and 64. If you skip count by 16s, you will arrive at 32. That's 16 times 2. And then if you continue, you will arrive at 64. This is a multiple. Number 3, which statement is true? So we have all these statements about prime or composite, and we have to figure out which one is true. The only factors of 3 are 3 and 1, therefore 3 is prime. So think about the number 3. I can multiply 1 times 3. Can I multiply 2? No. 3? That's the same as this. 3 times 1, it's just that commutative property and they're flip-flopped. So this is true because this number is prime. I'm going to check the other answers just to make sure. Letter B, the only factors of 4 are 4 and 1. Therefore, 4 is prime. Well, I know I can multiply 1 times 4, but I can also multiply 2 times 2. So this is incorrect. Letter C, the only factors of 5 are 5 and 1. Therefore, 5 is composite. 5 and 1. Well, that sounds true. 1 times 5, which is the same as 5 times 1. So this part is correct. However, this word right here, composite, indicates that you have more than one factor. That makes this statement incorrect. Letter D. The only factors of 8 are 8 and 1. Therefore, 8 is composite. Well, I know I can multiply 1 times 8, but I can also multiply 2 times 4. So this part right here, 8 and 1, that is wrong. Therefore, D is incorrect. Number 4. Determine if each number is prime or composite. Then write all the factors for each number. So I'm actually going to write down the numbers first and think to myself, okay, what are the factors? Because we have to know how many factors they have really to determine if the number is prime or composite. So for 19, I can multiply 1 times 19. Does 2 go into 19 evenly? No. 3? No. 4? No. 5? No. 6? No. 7? No. The only numbers that I can multiply that will equal 19 are 1 and 19. So 19, we know, is prime. Now let's look at 33. I know that I can multiply 1 times 33. Right away, if you really studied your facts last year, then you probably recognize something special about this number. These two double digits here that are the same. If you know your facts, then you know that 11 times whatever number will give you these double digits. So the other factor is 3. 3 times 11. Therefore, this number is composite. Last one. On page 285, we're on question number 5. Select all equations that have a dividend, so a dividend, that is a multiple of 4. So we're talking about the big number that's being divided. So we're focused on those numbers. A multiple of 4 and has a quotient, that's the answer, that is a factor of 18. Wow. So first let's look and find out, are these all multiples of 4? 8 is a multiple of 4. 18 is not a multiple of 4. I can't multiply 4 by anything to equal 18, so I'm going to put an X there. What about 36? I know that 4 times 9 is 36, so that could be right. We said the first one could be right. Now let's look at this one, 48. Does 4 go into 48 evenly? Yes, it does, so this could be correct. And then 16, the last one. This one could also be correct. But now we have to look at the second part of the problem, a quotient that is a factor of 18. So now we have to look closely at the answer for these that are possibly correct. And we have to determine which of those are a factor of 18. Can I multiply any number by 2 to equal 18? Yes, I can. 2 times 9. So this one is correct. Does 12 go evenly into 18? No. What about 6? Yes, 6 times 3. So this one is correct. And what about the number 4? Does 4 go evenly? No, it does not. Okay, we're going to stop right there. In the second video, we'll pick up and go through problems 6 through 13. Again, please make sure you've completed these problems before watching the video.